Hello everyone. In this session, we will see about trees. In the last previous sessions, we were seeing about stacks and queues and arrays and linked lists, which are belongs to linear data structures. And here, the topic which we're going to see today is trees, which belongs to nonlinear data structures. So, what's nonlinear data structures? So here, the data will be stored very much in random places, where compared to arrays and linked lists, which will be stored in sequential ways. So that's a trees. So group of data into trees, it belongs to nonlinear data structures, and then the worst case timing is going to be order of log n. So here it will represent a data contains a hierarchical relationship among the elements, example family or record. So the trees can be defined in many ways, the recursively. So we will call the same function again and again and again, and then we can store the data. So we will see in detail in the upcoming sessions. So what is a tree? It's a consist of collection of nodes arranged in hierarchical pattern. So whereas here, if we can observe, under a root there are a lot of nodes. Under a there are a lot of nodes. But if you observe, there is no cyclic path. Whereas here, which forms cyclic path, which is not belongs to tree. And then if there is no cyclic path, and then having specific nodes comes under a specific node that is called a tree. So before going into the concepts of trees, we should know the terminologies which we are going to use in the trees. So these are the different terminologies which we have in the trees. So we will see one by one. The root. That's a starting node of a tree is called root node. Only one root node will be available in a tree. So in this example, A is the root node. And then edges. So edges is nothing but connection of nodes. So how do you connect the nodes? By a line, that is called edge. So between A and B there is a line, that is called edge. Between B and D there is a line, that is called an edge. So if you have an n number of nodes, then in a tree there will be n minus 1 edges. So if we have 6 number of nodes, then we have an n minus 1, that is equal to 5 number of edges. Next one is called parent. So a parent means what? It have one or more children nodes. So for example, in this example, you can see here, B have a children that is called D and E. D have a children that is called F. So D is called parent of F, and then so D is called parent of F, and then B is called as a parent of D and E, and then A is called as a parent of B and C. So these are the parent, and then we can call them as a child. Who are we will call them as a child? So the B and C are the child of A, D and E are the child of B, and F is the child of D. So all nodes except root node or child node, because A is a starting point. So A cannot be a child of anybody. So here B and C are the child of A, and D and E are the child of B, and F is a child of D. Siblings. So siblings means if both number of nodes of or if number of nodes having the same parent, that is called siblings. In this example, B and C are the siblings of A, D and E are the siblings of B, and F is a single child. There is no siblings for F. So the D and E are the siblings and B and C are the siblings. So D and E are having a same parent, that is called B. B and C are siblings. Why we are calling B and C are siblings? Because the same parent of B and C is going to be A. That is called siblings. And then degree of a node. So the degree of a node, the number of children per node. So A is having a number of children. B and C are the number of two number of children, and B is having a D, E, F. There are three number of children. So degree of B is going to be 3. And C is having no children, so 0. Likewise, D, E, F, it is 0. So the degree of entire tree is going to be highest degree of a node among all the nodes. So for B is going to be 3. So that's the maximum of all the nodes going to be taken as a degree of an entire tree. That is called 3. And the next one is internal node. A node with minimum one child. So the node with minimum one child except root node, we have a D, E, F. So B is called internal node, where C doesn't have any child nodes, so you cannot call C as an internal node. In the example of this tree, B is called as an internal node. Then whichever the node doesn't have a child, that is called an leaf nodes. So D doesn't have any child node, likewise C, likewise F, likewise C. So these are called an leaf nodes. D, E, F and C are called as an leaf nodes. Next one is level. So each step of tree is a level number. So it will start from root. It will start from level 0. So the root node is in level 0 and the child of root node is called level 1, and then child of B and C are in level 2, and child of D, E, F, G, H are in level 3. These are the level of an tree. Height, where height is nothing but the longest path from the node to any leaf node, the longest path. So I can form a longest path to the A to G. Okay, so A to G is number of edges are 1, 2 and 3. So height of A is 3 because that is the longest path. A to E also there, A to F also there, or A to C also there, but those are not a longest path. The longest path for the node A is called an to the G only. So height of B. Height of B can be transferred from B to G or B to E or B to F, but the longest path is B to G. So number of edges are 2. So height of B is 2. Likewise D, it is 1. For C, G, E, F, it is 0. So height of a tree is equal to height of a root node. So for root node is 3. So that is the height of a tree. Next one is depth. Where height we started from the root node to the leaf node, depth means leaf node to the root node. That's the opposite of the height. So for G is going to be to the root node 1, 2, 3. So depth of G is 3. D, E, F 1, 2 for D. For E, E to B is 1 and B to A is 2. For F, F to B is 1 and B to A is 2. So DEF is 2. For B to C, to the root node is going to be only 1 edges. For A is going to be 0. So depth of the tree is nothing but depth of the longest path from the leaf to root. Leaf to root. And then subtrees. So we are calling a single node also as a root node, a single node also as a tree. So for A, the subtrees are B, D, G, E is subtree and C and H are subtree. For B, the subtrees are D and G, and then E is another subtree. For D, the subtree is called G, and for E, nothing. For C, H is a subtree. So even a single node that is called as a subtree. Next one is forest. A forest is nothing but collection of different number of trees. So you can see here, this is a one tree and this is another tree. So collection of disjoint trees, those are called in forest. Next one is path. A path from a node to a and another node define a sequence of nodes. So for A to G, the path is A to B and B to D and D to G. That's a path. Likewise for E, A to B and B to E. For F, A to B and B to F. For C, A to C only. That is a path. A length of the path. A length of the path nothing but number of edges in the path. So for A to G, the number of edges are 1, 2, 3. For A to E, number of edges, length of the path is going to be number of edges. So 1 and 2. For A to F, the length of the path is going to be A to B is 1 and B to F is another one. So 2.